Hey, good morning, geometry. So I want to pick up today where we left off yesterday. Yesterday, we were still looking at that 30, 60, 90 right triangle, and we had said, hey, if you know the short leg, you know the hypotenuse is double. And then in our video session, we were like, but what about this leg here? And we used some Pythagorean theorem magic to walk through that we knew that this leg here was square root of 3, which we wrote as 1 square root of 3, and then Emma was like, hey, I see a pattern there, that this is the length of that short leg times root 3. And then we're like, well, what if we tried another one? And so we tried another one, and we're like, hey, when this was 2, this was 4, and Pythagorean theorem, and we're like, oh, that was 2 root 3. And so when this was 2, this leg here was 2 root 3. And Emma's like, yeah, still, I see that pattern. And Philip was like, yeah, I see that pattern too. And then we did another one. And we're like, yeah, that pattern still works. And then finally we're like, okay, maybe we could generalize this. And that's where I want to start today. What if we tried to prove this guy here? Okay, so let's say that I've got myself a 30, 60, 90 special right triangle. Let's say this is 30 degrees here. Based on what we already know, if this is x, the hypotenuse is double that. That's the relationship that we practiced yesterday. And the question is, what's this other side? Okay, so I could use my variables and the Pythagorean theorem to try to figure out what is this question mark. Okay, so let's do that. X squared, this leg squared, plus question mark squared is equal to the hypotenuse squared. Okay, well now let's be careful with our algebra here. 2x squared means 2x times 2x. Okay, let's think about 2x times 2x. The 2 and the 2 times 2 is 4, and x times x is x squared. So x squared plus something squared, and that's what we're trying to find, is equal to 4x squared. And now I want to move this guy here, combine up my like terms. I'm going to subtract x squared from both sides. So something squared is equal to 3x squared. How am I going to solve for that question mark? Well, I think I need to take the square root of both sides. So the square root of question mark squared is just question mark. And now I need to figure out what this guy here is. Okay, so keep in mind, this is a product. So I know that that means that it's the same as root 3 times the square root of x squared. But the square root of x squared, oh my gosh, what is the square root of x squared? It's just x. So question mark is equal to root 3 times x, which I'm just going to go ahead and commute those terms because I usually like to have my irrational part of a product come second. So question mark is equal to x root 3. And that's the pattern that we found yesterday. So let's come back up to our picture. If this guy here is x, the hypotenuse is double that, and the other side is just the square root of 3 times whatever that initial length was. So, for example, if I had a 30, 60, 90 triangle, and I knew that this side here was 7, that this side right here was 7, this other leg is going to be this length times the square root of 3. And the hypotenuse is just double that short leg, 14. All right, I'm going to give you some practice problems to try. And, you know, the tricky thing, it's not really tricky. But the thing to keep in mind is when we put these all in context with other triangles, our other special right triangles, our 45, 45, 90s, you just really have to keep in mind which pattern we're talking about. So 30, 60, 90, the short leg, if I double it, that's the hypotenuse, and the other leg is the short leg times root 3. So short leg times root 3, short leg doubled.